that, too. But above all, is the sky a social phenomenon? The sea? A rainbow? Is the sense of vastness that blue creates? Blue is physics. Back then, aboard the ferry, I couldn't have explained it precisely, but I knew that the sky and the sea are blue because light of a certain wavelength interacts in a particular way with the molecules in the air and the water. Blue is chemistry. Lapis lazuli develops under certain conditions in Earth's crust when limestone comes into contact with hot magma. Dyeing with indigo demands some clever chemistry in order to transfer the blue pigment to cloth. It is the behavior of these pigment molecules that we have to thank for our much-loved denim. And one of the shades of blue used by Picasso was developed by alchemists in Berlin, who were actually looking for a wonder drug to cure all disease. Blue is biology. Long before painters were bringing beauty to a canvas with their brushes, there were shimmering blue butterflies and flowers blooming in blue. Evolution produced them, as it did our ability to appreciate the colorful spectacle of life. Blue is special. It occurs less frequently in nature than other colors do, as Goethe himself noted in his theory of colors. Why? What does science know about the color blue? What is the connection between all these things we admire? The butterflies and the berries, the sea and the stones, and our senses. How much more beauty is there for us to discover if we know what it is that connects them? In short, how would I explain blue to a person who can see? Blue stones such as lapis lazuli or sapphire derive their color from grids of crystals in which elements such as sulfur, iron, copper, or cobalt arrange themselves in a particular way. Humans have learned from some of these stones how to create inorganic pigments in order to use them in our art. In plants, it is organic pigments, large molecules based on carbon, that make them appear blue. These inorganic and organic pigments form the basis of most of the shades of blue around us. In the animal world, blue comes about in a different way. Most animals manage without any blue pigments. Instead, tiny patterns on their bodies' surfaces manipulate rays of light directly so that blue light is intensified. In birds' feathers and butterflies' scales, nature has mastered a technology that humans are only just beginning to understand at the dawn of the 21st century. Yet the beauty of all these stones, plants, and animals also lies in the eye and brain of the beholder. Our eyes transform the rays of light they reflect into electrical signals. Our brain interprets these signals, and our language arranges these impressions into colors. Blue is not out there, and it is not inside us either. The radiant blue of a cornflower is a kind of collaboration between us and the plant. The poet John Keats felt that Isaac Newton had unweaved the rainbow. But science is actually doing the opposite, elucidating what holds the world together at its core. It reveals connections where we do not suspect any, until we discern the blue of a butterfly's wing in the shimmer of a soap bubble, the blue of lapis lazuli in a painting in the museum, or the blue of the sky in a friend's blue eyes. That may not sound like much, but I hope that it is enough to let us see the beauty of nature. My hope is that my illuminating these connections will allow us to see the beauty of nature with fresh eyes, and perhaps it will also help us to better understand the